So the next one is higher order components. This is again higher order components. We will be talking about React's higher order components from the advanced guide. I will do a step-by-step walkthrough of the documentation. I'm reading this for the first time, so it is for me to learn and at the same time broadcast it also. So higher order components, a higher order component is an advanced technique in React for reusing component logic. Okay, so looks like this is a way to reuse component logic. HOCs are not part of the React API per se. So higher order components are not part of React API. So they are a pattern that emerges from React's component nature. So this is just a pattern that emerges from React's component nature. Concretely, a higher order component is a function that takes a component and returns a new component. Okay. So it looks like it takes a new component and returns a new component. Yeah. So whereas a component transforms props into UI, a higher order component transforms a component into another component. HOCs are common in third-party React libraries such as Redux, Redux's Connect, and Relay's Create container. This document will discuss why higher order components are useful and to write your own. Use HOCs for cross-cutting concerns. So we previously recommended mixins as a way to handle cross-cutting concerns. We have since realized that mixins create more trouble than they are worth. Read more about why we moved away from mixins and how you can transition your existing components. So looks like they're saying HOCs can be used for cross-cutting concerns. So components are the primary unit of code reuse in React. However, you'll find that some patterns aren't a straightforward fit for traditional components. For example, say you have a comment list component that subscribes to an external data source to render a list of comments. So they're saying that components are the primary unit of code reuse in React, but they're saying that there are some patterns that aren't straightforward. And basically for those patterns, you cannot use the traditional React components. So they're giving an example here. So it looks like there is a comment list component that subscribes to an external data source to render a list of comments. So let's see what that comments list is. So this comments list looks like it's subscribing to something external to render all the comments. Let's see what it's doing. So as soon as it mounts, so we'll go from the top comment list. Again, it's a simple React component. And looks like there is a handle change. There is a change event and a handle change method associated with it. And in the state, we keep track of the comments. Data source is some global data source. Okay. So this is how we initialize it. And then as soon as we mount, we are saying add change listener. Okay, basically we want to make sure whenever there are changes to the comments, we want to be notified. Component will unmount. So this component will unmount. Here we are saying data source dot remove change listener. This dot handle change. So basically, I think looks like data source is a global object, and it supports a method called add change listener. And then it also supports another one called remove change listener. And then handle change is the method that will set state. Basically, it will update the contents as soon as we get a new set of contents. So, and then because we are changing state, so whenever the contents change, we go ahead and create a new, we create a div, we are creating a JSX object whose contents will change also whenever the comments change. So they're saying that's pretty simple. They're saying later you write a component for subscribing a single blog post, which follows a similar pattern. Okay, so you have a blog post, and then you're adding a change listener, or you're subscribing to only, you want to know only comments written to a particular blog post. So okay, so this one subscribed to only a particular blog post. What is text block? So looks like text block is some other React component. Oh, we are rendering that. Okay. Whenever there are changes detected to the blog post contents, we are re-rendering it. So let's see. So comment list and blog post aren't identical. They call different methods on data source, and they render different output. But much of their implementation is the same. On mount, add a change listener to data source. Inside the listener, call set state whenever the data source changes. On unmount, remove the change listener. Let's see. Yeah, it looks similar. So basically, that is similar. Yeah, that is similar to this. Yeah, it's exactly the same. This and this are exactly the same. They're saying there are commonalities like that. Understood. So yeah, inside the listener, both of them called set state. Yeah. But what they set is a little different. On unmount, they both of them call this remove change listener. So you can imagine that in a large app, the same pattern of subscribing to data source and calling set state will occur over and over again. We want an abstraction that allows us to define this logic in a single place and share them across many components. This is where higher order components excel. We can write a function that creates components like comment list and blog post that subscribe to data source. The function will accept as one of its argument a child component that receives the subscribed data as a prop. Let's call the function with subscription. So they're saying we can write a function that creates components like comment list and blog post. So basically, they're saying we can write a function called with subscription, which will either take a blog post or comment list, and the second parameter will take obviously something else. So the first parameter is the wrapped component. So first parameter is the wrapped component. The second parameter retrieves the data we are interested in, given a data source and the current props. Okay. When comment list with subscription and blog post with subscription are rendered, comment list and blog post will be passed a data prop with the most current data retrieved from data source. Okay. So they're saying when comment list with subscription and blog post with subscription are rendered, comment list and the blog post will be passed a data property with the most current data retrieved from data source. Okay. Let's see how this works. They wrote a function with subscription, wrapped component, select data, and basically this is returning a class, the constructor props, handle change event, data select data, data source props. Okay. Okay. So basically this is all the common code. They wrapped it inside a function like this. Okay. So this is a reusable function, and they're saying that a higher order component. I wonder if they call this function the higher order component. It's making common methods. It's wrapping common methods in different components, and this can be reused. Is what is what they're saying. So this function actually is returning a React component with all these things. Okay. So note that a high order component doesn't modify the input component, nor does it use inheritance to copy its behavior. Rather, an HOC composes the original component by wrapping it in a zero, and that's it. The wrapped component receives all the props of the container along with the new prop data, which it uses to render its output. The HOC isn't concerned with how or why the data is used, and the wrapped component isn't concerned with where the data came from. Because with subscription is a normal function, you can add as many or as few arguments as you like. For example, you may want to make the name of the data prop configurable to further isolate the HOC from the wrapped component. Or you could accept an argument that configures should component update, or one that configures the data source. These are all possible because HOC has full control over how the component is defined. Like components, the contract between with subscription and the wrapped component is entirely props based. This makes it easy to swap one HOC for a different one as long as they provide the same props to the wrapped component. This may be useful if you change data fetching libraries, for example. Okay. So don't mutate the original component. Use composition. Okay. Resist the temptation. They're saying don't mutate the original component. So basically, they're saying don't dump more things into a. Instead of that, use composition. So basically, make the component as atomic as possible is what they're saying. Anyway, we'll see. So which is a good idea. I think it should do, a component should do only one thing, and that one thing good. And then you can use composition, basically build it brick by brick. If you want to build a house, you don't want to build build a house in one shot. You want to build it brick by brick, wall by wall, is what I'm guessing what they're talking about when they say composition. So resist the temptation to modify a component's prototype or otherwise mutate it inside an HOC. Okay. So there is a function called log props, and it takes an input component dot prototype dot component will receive props, next props. So the fact that we are returning the original input is a hint that it has been mutated. Enhanced component will log whenever props are received. So there are a few problems. They're saying do not do something like this, is what they're saying. So there are a few problems with this. One is that the input component cannot be reused separately from the enhanced component. More crucially, if you apply another HOC to enhanced component that also mutates, component will receive props. The first HOC's functionality will be overridden. This HOC also won't work with function components, which do not have lifecycle methods. So mutating HOCs are a leaky abstraction. The consumer must know how they are implemented in order to avoid conflicts with other HOCs. Instead of mutation, HOCs should use composition by wrapping the input component in a container component. So they're saying instead of mutations, HOCs should use composition by wrapping the input component in a container component. Okay. So this HOC has the same functionality as the mutating version while avoiding the potential for clashes. It works equally well with class and functional components. And because it's a pure function, it's composable with other HOCs or even with itself. You may have noticed similarities between HOCs and a pattern called container components. Container components are part of a strategy of separating responsibility between high-level and low-level concerns. Containers manage things like subscriptions and state, and pass props to components that handle things like rendering UI. HOCs use containers as part of their implementation. You can think high-order components as parameterized container component definitions. Convention pass unrelated props through to wrapped component. HOCs add features to a component. They shouldn't drastically alter its contract. It's expected that the component returned from an HOC has a similar interface to the wrapped component. HOCs should pass through props that are unrelated to its specific concern. Most HOCs contain a render method that looks something like this. Okay. Basically use the spread operator to pass the and they're using the spread operator and something like injected prop. Okay. So this convention helps ensure that HOCs are as flexible and reusable as possible. Okay. So I didn't understand this fully, but this is not a full example. Basically, they're saying that if you have a bunch of pass-through properties, then send the pass-through properties to the component, and then if you have to inject props into wrap component, looks like this will be state values or instance methods. We could do it like this. I wonder what happened to this extra property. So convention, maximizing composability. Not all high order components look the same. Sometimes they accept only a single argument, the wrapped component. Navbar with router equals with router navbar. Usually high order components accept additional arguments. In this example from Relay, a config object is used to specify a component's data dependencies. The most common signature for HOCs looks like this. Okay. I wonder what this comment means. So it looks like this high order components, I need to dig a little deeper into it. So usually HOCs accept additional arguments. They're saying they accept, in this example from Relay, a config object is used to specify a component's data dependencies. So here in Relay, it's taking a wrapped component as the first argument, and the second one, it's taking another one called config that specify components' data dependencies. So the most common signature for HOCs looks like this. Looks like this is the most common signature. So they Here, here a high order component is taking comment selector. I'm guessing it will be the wrapped component and comment actions. I don't know what that is. I don't know what this is. What is it doing? So I wonder if this is returning. So if this is returning a function, and that function will take comment as its argument, and comment itself is another wrapped component, and these are some other arguments. So anyway, what if you break it apart? It's easier to see what's going on. Okay, that's okay. He's doing the breaking apart. So connect is a function that returns another function. Okay, understood. So let's say current. So it's returning a function called enhance, and enhance is taking comment list, a wrapped, so a wrapped component. So they're saying the return function is a HOC, which returns a component that is connected to the Redux store. Okay. In other words, connect is a high order function. So they are saying connect is a high order function that returns a higher order component. So it's a high order function that's returning a higher order component. This form may seem confusing or unnecessary, but it has useful property. It has a useful property. Single argument higher order components, like the one returned by connect function, have the signature component. Okay. Functions whose output type is the same as its input type are really easy to compose together. Anyway, this code is getting more complicated as I go through it, and I don't fully understand it. I understood till here what they're trying to do, but here basically you're chaining something. Is this what is being used for? So this looks like a big chain call. Looks like this is returning a function, and it takes this argument. Oh, and so this is returning a function, and with router blah 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 is returning. So this one is returning a wrapped component, and this higher order function takes that wrapped component as its input, another higher order component, if I understand this. Oh, so they're saying instead of doing this, you can use a function composition utility. Okay. So they're saying instead of doing something complex like this, maybe to make the code reusable, you can use a function composition utility. So basically, compose FGH is the same as ... args. Okay. So the output of f args is the argument for G, and the output of that is an argument to F, is what they're saying. Okay. So the same property also allows connect and other enhancer style HOCs to be used as decorators, an experimental JavaScript proposal. The same property also allows connect other enhancer style HOCs to be used as decorators, an experimental JavaScript proposal. So the compose utility function is provided by many third-party libraries, including Lodash, as Lodash.Fluoride, Redux, and Ramda. Okay. So convention, wrap the display name for easy debugging. So the container components created by HOCs show up in React developer tools like any other component. To ease debugging, choose a display name that communicates that it's the result of an HOC. The most common technique is to wrap the display name of the wrapped component. So if your higher order component is named with subscription and the wrapped component's display name is comment list, use the display name with subscription comment list. Okay. Okay. So looks like for better debugging, so they're saying set the display name, property to the display name from the wrapped component is what they're saying. Okay. So the display name is a custom function which will check the wrapped component's display name. If it is not there, then it'll give the name of the wrapped component itself. If it is not there, then it'll say, hey, it's a component. Basically saying it's a React component. So caveats, higher order components come with a few caveats that aren't immediately obvious if you're new to React. Don't use HOCs inside the render method. They're saying don't use it inside render method. React's diffing algorithm called reconciliation uses component identity to determine whether it should update the existing subtree or throw it away and mount a new one. If the component returned from render is identical to the component from the previous render, React recursively updates the subtree by diffing it with the new one. If they are not equal, the previous subtree is unmounted completely. Normally, you shouldn't need to think about this, but it matters for HOCs because it means you can't apply an HOC to a component within the render method of a component. So here they're saying a new version of enhanced component is created on every render. That causes the entire subtree to unmount and remount. So basically they're saying, hey, don't use it within render. The problem here isn't just about performance. Remounting a component causes the state of the component and all of its children to be lost. Instead, apply HOCs outside the component definition so that the resulting component is created only once. Then its identity will be consistent across renders. This is usually what you want anyway. In those rare cases where you need to apply an HOC dynamically, you can also do it inside a component's lifecycle methods or its constructor. Static methods must be copied over. Sometimes it's useful to define a static method on a React component. For example, okay, sorry for the interruption. I think so anyway, this static, when you apply HOC to your component, though the original component is wrapped with the container component, new component does not have any of the static methods of the original component. Static methods. Static methods must be copied over. Sometimes it's useful to define a static method on a React component. For example, relay containers expose a static method, get fragment, to facilitate the composition of GraphQL fragments. Okay, static methods must be copied over. Sometimes it's useful to define a static method on a React component. Static methods must be copied over. Okay, lost. Anyway, I think going, I missed part of it. There was a distraction. So basically they're saying the static methods must be copied over. And so wrapped component or static method cost. Okay. So, okay. So basically you have to manually copy it over, I think, to solve this. So basically the wrapped component has a static method. If I enhance that component and the static method is undefined. So to solve this, you could copy the methods onto the container before returning it. You could copy the methods onto the container before returning it. So, okay, so I can inside the enhance, I can copy the method and then return it. Ugly. So, however, this requires you to know exactly which methods need to be copied. You can use hoist non-react statics to automatically copy all non-react static methods. Oh, okay. So there is a module, there is a package available for that. So basically use that package. Another possible solution is to export the static method separately from the component itself. So another possible solution is to export the static method separately from the component itself. And this is easy enough, I think. So another possible solution is to export the static method separately from the component itself. So instead of doing something like this, they're saying export the method separately. And in the consuming module, they're saying import it. What a mess. So I think this is good enough. I don't know why I would choose something like this over this. So refs aren't passed through. So while the convention for high order components is to pass through all props to the wrapped component, it's not possible to pass through refs. That's because ref is not really a prop like key. It's handled specially by React. If you add a ref to an element whose component is the result, so occasionally users who are new to React paradigm rely on refs in situations where a prop would work better. That said, there are times when refs are a necessary escape hatch. React wouldn't support them otherwise. Focusing an input field is an example where you may want imperative control of a component. In that case, one solution is to pass a ref callback as a normal prop. by giving it a different name. Okay. So it looks like we have to fake it by creating a property and then pass the ref as a property. This is not a perfect solution by any means. We prefer that refs remain a library concern rather than require you to manually handle them. So we are exploring ways to solve this problem so that HOC is unobservable. Okay. So anyway, this guide did not go well. At a high level, I understood what HOCs are. So they can be used for cross-cutting concerns. So there is some code reuse using this. Give me 2 minutes. I'm almost done with the code. So if you don't mutate the original component, use composition. Okay. So maximizing composability. Okay. Wrap the display name for debugging. I think we need to make sure we wrap the display name for easy debugging. There are a lot of anyway. I think that said, the static methods. I think for static methods, use the hoist non-react statics import. And refs are in pass through. Okay, for refs, I think create a property and pass it as a property. So that's all I have for this one. I think the next one will be integrating with other libraries. I'll start another video for that.